All right, this video is to try to give you a little more information on how to select your topic and also to kind of organize where that topic's going to take you as you get into your own data collection later on in the course. So what we're going to do is we're going to look at several different options and we're going to kind of compare how many groups you want to talk to what variables are we interested in about those groups, and we're going to do that for each particular topic. So I'm going to start out with qualitative. So if you already know the data that you're going to collect is in categories, this is your categorical variables, you can't compute means on them. These are, I'm going to ask a question and the answers are going to be yes or no, or the answers are going to be blue and green. Then several different things could happen here. Here's one example. So this is a qualitative one sample, one variable. So a survey claims that 9 out of 10 doctors recommend aspirin for their patients with headaches. So what I would like to do is I would like to take this percentage, which is usually the only thing that we can calculate about qualitative data anyway. But this is a given percentage. This is not a percentage that I actually collected my own data for. And I just want to compare what I get to what I've already been given. So I'm really only going to talk to one group of people, and that's probably going to be a group of doctors. And I'm only looking at one variable where I'm interested in, do you give aspirin to your patients? Okay. By no means should I ever do a study where I'm the one giving the aspirin, because that's not ethical. You nor I are licensed doctors, so we can only ask the question of someone who is licensed. So we're just going to ask one group of doctors whether they give aspirin or not, and once we get our result for this question, we're going to compare whatever percentage we have to the original percentage that was given to us to see if there's a difference. All right, another example of a qualitative setup is 2 samples, 1 variable. For example, the university financial aid officer samples undergraduate students to determine whether male or female students are more likely to get a summer job. So this time when I look at those groups, I'm actually going to be talking to 2 groups. I'm going to be talking to females. I'm also going to be talking to males. But what I'm interested in finding out is whether or not they got summer jobs. So there's only one thing that I'm interested in, but I'm going to talk to 2 different groups about the answer to that question. So because this is qualitative, we really can just get a % for the females, a % for the males. We're not comparing that to anything that was giving it to us in the beginning. This is all fresh data, so what I'm looking for is to see, is there a difference between these 2 groups? Another thing that could happen with qualitative variable is if I have 1 sample, but I'm actually interested in 2 different things about that sample. So you're comparing 2 different categoricals, and technically you don't, it may be more than, well, this one's kind of weird. So I've got 1 sample of people, but I am looking at 2 different things about them. So I'm still looking at females versus males. So it looks like 2 groups, even though I'm picking them all together. So that's why I'm viewing it as 1 sample. Whereas on this one, I collected these and then I collected these separately. So that's a difference. We'll talk about that a little more when you actually start collecting your data set. And I want to look at 2 or more variables. So are they Democrat? Are they Republican? Or are they independent? So we're looking at multiple things, but all of these are categorical because I can't measure gender and I can't measure your political affiliation. So we're looking at the percentages in each one of these categories, and we're trying to determine if there is an association between the two. Do females tend to lean towards one party over another, or do males tend to lean towards one party or another? Qualitative, if you're looking at the distribution of one variable. So you're trying to match a percent distribution that has already been given to you. For example, if you look on the M&M's website, they will tell you what percent of each color of candies are supposed to be in their packaging. And I can't tell you right off the top of my head what those percentages actually are, but they might tell you that 10% of each package that they sell should be blue, 20% of each package should be orange, 30% of each package should be green, and so on and so forth. So what you would be doing is getting a package of M&Ms, and you would be recording for each variable what you got. Blue, orange, green. Well, in my package, I got 12%. And in my package, I got 25% orange. And so on and so forth. And you would be taking these values and comparing them back against the percentages that were given to you to try to determine if what they claim to be in their packaging is actually true. Another one, if you have two different variables and you're looking at, let's say, TV viewing preferences, we might ask respondents to identify their favorite program. So we're going to ask the same question of two different populations. So we have males versus females, and maybe we section off categories. Do you like romantic comedy best? Do you like sci-fi best or history best? And you get the percentages for each one of those sections. Now that looks a lot like the previous two that we did. However, for this one, we were looking for an association between them. Does one tend to like more than the other? This one, we were matching against a percentage we already had. This one, what we're looking to see is if there's a difference between the two groups. Now, that can be very confusing. So if you have narrowed your qualitative question down to one of these last three, and you need help kind of narrowing it down and pinpointing which one of them it's supposed to be, feel free to contact me, or if you're in Danville, feel free to contact one of your math teachers down there. Okay, so if you're doing a qualitative topic, you don't need to look any further. Quantitative topics, remember, we move away from percentages and now we're looking at averages. We're looking at means. These are numerical data collection that we can actually do those calculations on. So one example of that is you have one sample, one variable. So let's say your company wants to improve sales, and you already know that in the past, the average has been $100 per transaction. And after you train your sales force, you want to analyze the recent sales data. So you're only going to look at your team, your one sample, and you're going to look at the new sales data, the one variable you're interested in, and you're going to come up with the new average. So you're only actually looking at one sample, and you are comparing it to something that was already established to begin with. Another type 2 sample one variable. Let's say you want to compare the average cycle time, again, keyword average, to deliver a pizza from company A and company B. So you're actually going to look at two different samples, company A being one, company B being another, but you're still just interested in one thing. What is the cycle time that it takes to deliver this pizza? So you're going to have an average time from A, you're going to have an average time from B. This time you're not comparing it to something that was already given it to you. You're just trying to look to see, is there a difference between the two? Okay, if you're looking at an association between two variables, and we like your GPA versus your SAT. Do they have anything to do with each other? This is a data set that could be represented as a scatter plot. So if I collect one sample, and for each student I plot what their GPA was with their SAT score as an ordered pair, I can look at the scatter plot to see if there is an association between the two. Okay. And finally, this is quantitative data with 3 or more groups, 1 variable. So let's say you have a group of individuals randomly split into smaller groups. For example, you might be studying the effects of weight loss on groups of green tea, black tea, and no tea. But for all groups, you're looking at weight loss. This is another way that you could approach quantitative. This is very similar to a previous one, the difference being we've got 3 or more groups that we're looking at instead of 2. Okay, so I hope that clears it up for you. Again, please reach out to me if you're not quite sure where your topic fits, or if you think your topic needs to be tweaked some way in order to make it fit one of these categories. And again, if you're in Danville, just reach out to one of your math teachers at that location. Bye guys, have a great week.